Assalamualaikum and hi everyone. Today I'm going to talk about the time and motion study. Why it is very important and how to do the calculation on the time study. Okay, the outline for this topic it include the method analysis in which why we need to do the time study, and then I will introduce these two chart that is very important in the time and motion study, and also we need to do some calculation on the work study. Okay, and the important part is how to calculate the standard time. Okay, standard time is the time that it's one job will be completed. Okay, so it is standard time, so anyone who do the job, they will have to follow the guideline. Okay, what are the steps and what are the time that they should complete the job. Okay, let us like the one I mentioned just now, analyzing how a job gets done. It means that you have to know the step. You need to know what tools they are using, which hand they are using, and what are the other movement that needed to complete the job. So mostly, each job have their own procedure or have their own um, sequence and timing. Okay, is related to how to produce the SOP, standard operating procedure. Okay, why we need the motion and time study? Because we want to make sure that all the workers are protected. Okay, so that they don't have a problem with health, problem with their posture, so they don't have any job related illness. Okay, for example, this is the correct way how to lift heavy object. Okay, to make sure that we don't get this kind of problem in the future. Okay, why we need to do analysis? Okay, when there's a tools and equipment change, when you introduce new tools, when you introduce new equipment, so you have to document the process of doing the job. And then due to the product design, okay, there's a changes. Maybe they add more steps, maybe they add more parts that need to be assembled, so they need to do the time study, right? And then if introduction of new product, okay, that's very important because this is the first time the manufacturer will produce it, so they need to analyze and have everything documented. And then change in material and procedure. Sometimes there's a change in the regulation, okay, maybe due to the labor law. And then this is the main concern is when accident always happen at that machine. Maybe lately, like frequent report on accident happen. Okay, maybe we need to analyze how the job is get done. Maybe they give the wrong tools, maybe they give the wrong procedure. You need to do the analysis. Okay, and then quality problem. If we have lots of quality problem from that machine or from that line, so we need to know, is it due to the wrongly way of doing it, or maybe they give the wrong tools again. All right, so they need to do the analysis. Okay, for example, these are scissors. Okay, actually the scissors that you always found in the shop, they sell this one, the right-handed one. So it's hard for the left-handed to use this one. Okay, so if the job need to use scissors, if the person is left-handed, the correct way to handle it is you need to provide the tools for the left-handed people. You cannot assume that, okay, even you left-handed, you need to use the right-handed scissors. They will struggle. It takes lots or even longer time to adjust. Okay, for example, this kind of tools, okay, especially for the hand brace. Okay, this one, it's difficult when it's at the wrong side for left-handed. Okay, left-handed person. Same goes to the hand drill. Okay, so if you're left-handed, so you need to do the with the other hand, right? Ice cream scoop, as simple as ice cream scoop. For left-hander, it's gonna cause lots of trouble, and sometimes it take longer time than the normal process of ice cream scooping. Okay, this is the normal laptop. Okay, keyboard. You know, it's for the left-hander and the right-handed person. It's different. Okay, and mouse. Okay, this is the normal thing that we face almost every day. So the button for left-hander should be they have to customize. Okay, if they have a left-handed person. And measuring tape, this is a common one. Okay, for left-hander you will see upside down, right? Because they designed for the handed person. Okay, these are the analysis procedure. Okay, usually you don't do everything all at once, so you need to identify the line or operation that need to be studied. Usually with the line that or show that uh, there's a problem in it. Okay, maybe people complaining they have a backache, or they have maybe they stand too long, or maybe they have problem with their shoulder. Okay, because they are reaching something is too high. So from there we need to do analysis for that particular job. What are the root cause that make them feel with a stiff shoulder, or maybe they have a backache? So maybe something that need to be improved. Okay, and then we discuss, okay, the job with the person that are doing it and the supervisor involved, so that they know that we are observing them, we are recording their movement, we are recording the time taken. Okay, and then we study and document, and then we do analyze step by step. For nowadays they are using the video camera. Okay, so they put the camera at the line for the whole day. Okay, maybe a few times a week, so that they will consider if there's any abnormalities during certain days. Okay, or maybe and then the best thing is you must focus in the same line with the same operator doing it. So because sometimes different people have different way of doing it, so we need to be careful um, on the person doing it, and also on the angle that we are doing the video. Okay, and then we will document the step, we will document the timing. Okay, and then we need to follow up for improvement. Okay, all right. Guide, again, how to guide a job. So we need to make sure that it has a high labor content. So if the job include robots, 90% of the job is done by the robot, so you don't have to analyze the job, because 90% is from the robot. Okay, so unless the job that you want to study have more labor, more people doing it. Okay, so if you have more people doing it, it's the best place to start. And then the job, and then the line or the job done every day frequently, so you go for that particular line. If you observe and you heard about what you call it, complain, okay, on that line, so the best thing is to study that. And then when the line cause problem at the end, okay, maybe the end product have problem, have defect, and also there's a bottleneck. Okay, uh, many process delay on the line, so you need to do the study. Okay, we look at motion study. Motion study is more on the human motion. Okay, more on pergerakan, how the workers turn their body using their hand, how they reach something. Okay, is it too far? So we need to observe, okay, the movement. So these are the example. Okay, motion study principle. Okay, we need to know how far they are reaching for the tools. Okay, because we need to know the efficiency of the job done. Okay, these are the few technique. If you can see the few technique there, right? Micro motion, micro, you go detail into the every second of the movement. Okay, analysis of the blinks. Okay, motion study principle. Okay, usually we use the first one. Okay, and then there are two charts that I'm going to introduce to you. Okay, the flow process chart and the workers machine chart. Okay, the first one is the flow process chart. Okay, these are the example. Flow process chart, it use symbol. Okay, it use symbols to tell you story, to tell you the whole process. For example, we look at this. It tells us about process in getting for the payment of supplier. Okay, okay, we start with the this. We have steps. Okay, step 1 to step 6. Then we have time. Then we have distance. If they have to go to other department, if they have to walk to another place. Okay, and these symbols represent this meaning about this symbol. Okay, the round one is operation. Arrow is transportation. That means they move. Square means inspection. The semi the D-shaped one, it's the delay, and the upside down triangle on the storage. Okay, start. First is enter invoice to the system. Okay, so it's operation, you do the key in. It takes about 15 minutes. And then match the invoice with the purchase order. Okay, that's involved inspection. So you check. It's take about 10 minutes. And then send for authorization. So they have to walk 35 meters. So it took 5 minutes to get the authorization. Maybe they have to walk to another person's desk. Okay, and then wait for the payment to be authorized. It's delay because waiting, so it's about 60 minutes. Okay, it's quite long time for that. And then take it to the account office. It involved with the transportation, 60 meters. It takes 5 minutes. And then the last task is to operation pay the supplier. So you can pay the supplier. Okay, it takes about 25 minutes. So if you want to know the whole process of the payment, it takes about 15 plus 10 plus 5 plus 60 plus 5 plus 25. So this is the total processing time, and these are the distance. So by having this table and this symbol, you have the idea what is the whole process all about without writing any sentences. Okay, it's actually it convert the sentences into symbols. Okay, and the information is contained here, right? So it's very compact. Okay, these are the symbol that use widely. If you go anywhere in the world, mostly they will use the same symbol. Okay, symbol. So don't worry about it. Okay, this is another example. Again, remember operation. Okay, we have transportation, we have inspection, delay, and storage. So from here we know what the process is all about. It's about the steel plate in the store. Okay, so they are um, picking up the steel plate. Okay, and then move to the cutting gas cutting machine. So there must be movement. How far? 20 meters. It takes about 6 minutes. And then from the observation, they know that waiting cutting time to be machined. So there's a waiting time here. Okay, about 20 minutes. And then the operation, when the plate cuts into size, okay, it took about 40 minutes. And then after that, it moved to the machine shop. Movement, okay, transport 15 minutes, 15 meter. They have to move 50 meter. It took them about 12 minutes. And then finally inspected before machining. So operation, okay, and then it takes about 10 minutes. So from this operation, we can conclude that the waiting time, it's quite high, so we need to reduce this. Okay, and then the movement, for 20 meter it takes about 6 minutes. Okay, but this one for 15 meter it takes 12 minutes. Okay, we need to know what is the problem. Maybe the walkway, or maybe the ramp, they need to struggle. Okay, and then all of these, if you need to improve, we can improve on the timing. Okay. Okay, the next one is the workers machine chart. Okay, it tells about what? It tells about you between workers, people, and machine. How many percentage in the job that they use workers, they use people, human, and how many percent of the job that the machine doing it. Okay, for example, this is the machine part. Okay, so it involved with the operator. Okay, this is the human part, and then there's machine part. So from here we can read that the human will do the loading job, switch on, and then another switch on, and then idle means the workers are waiting because the machine is doing the job, and then pick up the parts is done by human, and then keep it in the tray done by human. Okay, these are the time. I think the time is in minute. Okay, so 0.2 minute, 0.08 minutes, so very short time because it's very easy task. And then for the machine, they need 1.5 minute. Okay, so when we add up all the minutes and then we do the percentage, we know that the 23.4% of the time is done by human, and the 76.6 is done by machine. Okay, so if you invest in a very expensive machine like CNC, okay, you need to have a higher utilization of the machine rather than human. So what for that you buy a very expensive machine, but human still doing half of the job, 50% is done by human. So it's, you want to know that the investment that you put in, is it worth it to have a expensive machine, so that we reduce the human utilization. Okay, okay, this is another example. Okay, this is for the process of hole punching here. Okay, so this is the hole puncher, this is the part. So we want to know, this is the time for operator for human, and this is time for machine. So pick up the sheet takes 3 minutes, and then start the machine 0.5, and then idle means that the machine is doing the punching, and then again the unloading is done by human. So we add up the time for human, and then we add the time for the machine, and we know that utilization for human is 83%. That is quite high, and then for machine is 17%. So they need to do something. Maybe they need to reduce the human utilization. Maybe they have to introduce automated, semi-automated loading system. Okay, so that they can improve or increase the utilization of the hole puncher. Okay. Okay, these are the two. Okay, these are the two chart that you need to know, because if you go for your practical in industry, uh, you will see this chart. Okay, the first one is the flow process chart. Usually, you can see on the job floor. Okay, on the shop floor, and then also workers machine chart. All right. So I will stop here first, and then next we will introduce you on the time study. Okay, so stay tuned.